Obtain the equivalent capacitance of the network in this figure for a 300 volt supply. Determine the charge and voltage across each of the capacitor. So let us draw this circuit for better clarity. Here this is C1, which is 100 picofarad capacitor, and these two are 200 picofarad capacitors, and these are C2 and C3. Now this is connected across a 300 volt supply through this capacitor C4, and here the C4 is 100 picofarad. So first of all, we'll find the equivalent capacity of this circuit. So we can say that this capacitor is in series with this part of the circuit. So we can just split this circuit in this way. This is our C4, which is 100 picofarad, and this C2 and C3 are in series, you can say. Each of them are 200 picofarad. Now C2, C3 is connected with C1 in parallel, which is 100 picofarad. This is my C1, and this total circuit is connected to 300 volt supply, and here this is given that this terminal is positive, this is negative, so I can take this as positive and this is negative. So this is the reduced form of the circuit. We can see here clearly that C2, C3 are in series, and this total capacity of C2, C3 is in parallel with C1. So we can say that the equivalent capacity of these two series 2 picofarad capacitors will be 100 picofarad, and 100 picofarad, 100 picofarad are in parallel. So they will be 200 picofarad. So I can redraw the circuit by taking C4, which is 100 picofarad, and here this will be 200, 200, 100 and 100, 100, 200 because of parallel. So this will be 200 picofarad. I can consider this T capacitor as this single capacitor. So this will be connected across 300 volt supply. Now here it is very easy to calculate because if you are taking this potential difference across this as V2 and potential difference across this C4 capacitor as V1, as we know that these two parts of the circuit are in series, we can say V1 plus V2 will be 300. As we know, in case of series connection, to find the potential across any of the capacitor, we can use this expression. That is potential V1, which is the potential difference across this C4. We can say that suppose we are having two capacitors. I am explaining like this, that is two capacitors C1 and C2, and a potential V is connected across this both capacitors, and I am having a potential V1 across this C1 capacitor and V2 across C2 capacitor. As we know, V across this C1 will be C2 by C1 plus C2 into V. So here we can find the potential across this C4 capacitor in this way. This will be 200 divided by 200 plus 100 into this supplied potential, which is 300. Now this is 200 plus 100, this is 300, and this is cancelled out. This will be 200 volt. As you know, these two potential will add up to 300 volt, and this potential is 200 volts. So obviously this will be 100 volts. So I can write here potential across C2, C3, sorry, C1 will be your 100 volt, and potential across this series of C2, C3 will be 100 volt. So as you know, C2, C3 are same capacitor, so we can say that their potential differences will be equal. So this 100 volt will be divided as 50 volt and 50 volt across each of the capacitors, that is C2 and C3. Now we can easily calculate the charges on each of the capacitors here. So our potential across, I'll write here, potential across C2 will be 50 volt. Potential across C3 will be again 50 volt. And potential across C1 is 100 volt, potential across C4 is 200 volt. Let us calculate the charges on each of the capacitors. As you know, this is a 100 picofarad capacitor, so Q through C4, I'll write that is CV. Capacity is your C4 is 100 picofarad, that is 100 into 10 to the power minus 12, into voltage is given across C4, that is 200 volt. So this will be 200 into 100, and this will be 10 to the power 4. So you can write 2 into 10 to the power minus 8 coulomb. This will be the charge on this C4 capacitor. We can calculate the charges on this C1, C2, C3 respectively. And here charge on this capacitor C1 will be again CV. Here the capacity is 100 picofarad, that is 100 into 10 to the power minus 12, and voltage is 100 again. So this will be 10 to the power 4 and 10 to the power minus 12, 10 to the power minus 8 coulomb again. And here C2, C3 will have same charge as they are in series connection. So we can calculate charge through C2, which will be exactly equal to charge through C3, and this will be CV, that is capacity is 200 into 10 to the power minus 12, and voltage is given as 50 volt. So this will be again 10 to the power minus 8 coulomb. You can also observe this circuit in this way. Total 2 into 10 to the power minus 8 coulomb is flowing like this. As you can see, this branch is having 100 picofarad in equivalent, and this is 100 picofarad. So we can say that this 2 into 10 to the power minus 8 coulomb will be divided equally, that is 10 to the power minus 8 coulomb and 10 to the power minus 8 coulomb through each of the branches, and there will be again add up here again this charge will be 2 into 10 to the power minus 8 coulomb, and this will be completing the circuit in this way.